All right, what's up, students? So today in class, this question came up and it seemed to be a little bit confusing for people. So I just wanted to clear it up. And it's this question of in the equation, work equals force times the cosine of theta x. Is this F an F net or is it just some plain F? And the answer to that question is sometimes. And that sometimes was, a little bit frustrating for people. So I kind of want to go through and just look at the two different types. And here's really what we need to be thinking about. Number one, you can have the work done on a system, or you can have the work done by a force. And depending on what you're going to be asked here, this right here will be a work total. So therefore, we are going to say that there is going to be some sort of F net, or the sum of all the forces acting on this entire system. Where when I want to look at the work done by just a force, then I'm just going to be looking at some F. Okay, so let's look at an example and see what I'm talking about here. If I had a box and that box was on a horizontal plane with no friction, okay, I would look at that box and I would say it has 3 newtons and the box is going to move a displacement of 5 meters. So I have this applied force here and I'd say, what is the work done by the applied force? Well, this becomes very easy. We could say the work done is equal to F cosine theta x. But we don't have to worry about this cosine because the angle between, that's why I put this cosine here. I put it in between F and X because this theta represents the angle between the force and the displacement. So I put it in between as kind of a hint. And the cosine of 0 degrees is 1. So we can simplify that and just say Fx. And when I go to plug in my numbers now, I can see that I have the applied force of 3 newtons and it moved the displacement of 5 meters. So the work done is just simply 15 joules of work. Okay? Now that is also the total work done because there's no other forces acting on the box. So really we don't have to worry about the difference between F net and F until I have, 2 forces acting on the box at the same time, because then I can ask 2 different questions. All right, so let's take a look at when there's 2 different forces acting on a box. Let's say, for example, with friction. So now I am going to have a box. It's going to move the same x equals 5 meters. Okay, and I'm going to have an applied force here that's going to be equal to 3 newtons. And I'm also now going to have a friction force that's equal to 1 newton. So now I can really ask 3 different questions to you. I can now ask for the work of FA. I can ask for the work of FF, or I can ask for the work total on the box. All right, so let's look at each one of those. So with the work done by just FA, it's going to be the same. Work equals Fx. So we have 3 newtons times 5 meters. That is equal to 15 joules of work. Okay, but now the work done by the friction force is going to be -1 because it's in the opposite direction. -1 times 5 meters. So the work done by this is really 5 joules, but in the negative direction. All right. So if we think about the 2 works of these together, we might hypothesize that the work total is actually going to be 15 joules minus 5 joules, which equals a total of 10 joules. Okay, which in fact is going to be the test right here. So now we have work total, which is going to be the sum of the forces, or Fnet, that are acting for X. Now we know the sum of the forces here is 3 minus 1. So we're going to have a net force of 2 newtons that is going to act for 5 meters. So the sum of this total work on the box is going to be 10 joules. And that's exactly what we thought it was going to be, okay? So it does not matter, guys. It's not a specific thing. When we look at when we look at work equals Fx, it depends on what I ask for. Am I asking for the work done by one specific force, or am I asking for the net total work done on this entire box? If you have any other questions about this, guys, let me know. I hope that cleared it up for you. Have yourselves an awesome, awesome day.